We began by watching each of the 3 video clips with selected frame grabs that displayed the sequential reaction of the friction ridge skin. In this process, we learned the advantage of using the stopwatch documentation because it time-stamped each response. We also discovered that the 8 LED lights from the camera reflected the fluid in the pores to make them visible as the skin responded to the breathing stimulus. Then, finally, we learned that some of the pores are active and other pores appear to be inactive or unresponsive to the breathing stimulus. I designated the active pores with red circles and then drew a perimeter around the non-active pores. You observed a 7-minute superglue fuming process reduced to only 2 minutes. The process began shortly after I made the controlled deposition, applied a line of superglue on the lid, and then sealed it up to be filmed with a digital camera. Like in the Pore video clips 1, 2, 3, you were able to observe the process sequentially, and the stopwatch time-stamped the response. In the video process, you could see the ridges appear and become more and more visible from the fuming process, until at a certain point, the reaction terminated. In this tutorial's commentary, I want to emphasize again active and inactive pore responses and enable you to view them in another format. First, you saw fluids in the skin response. Now you're going to study the matrix, the response of the fumes on the actual latent print deposit. The matrix is the substance transferred from the finger or palm to the evident surface. In this ground truth activity, I rubbed my hands together, which evenly distributed the oils and moisture from the fingers and palms. When my fingers made contact to the jar surface, the matrix transferred, making the latent print deposit. To begin my commentary, I'm going to refer to the 7-minute photograph of the superglue prints. It's my assessment that the white-gray coloration from the superglue process is indication of active and inactive pore responses. White coloration on the friction ridge is attributed to the minuscule pore fluid in the immediate proximity of the active orifice. The white arrows designate what I assess to be active pore sites. The gray coloration is attributed to the matrix that is lacking fluid in proximity to inactive pores. The gray arrows designate what I assess to be inactive pore sites. The superglue responds to the matrix, but the coloration difference is significant in this exemplar. Keep in mind, these responses exist even though I rubbed my hands together to purposely try to evenly distribute the moisture and oils on my fingers before I made the controlled deposition. Before I move on, look at the active and inactive pores. White arrow is active, gray arrow is inactive. At the end of the video clip, I used circle callouts to designate specific areas of the ridge surface at 1 and 7 minutes. Now the inquiry will expand to comparing the 1-minute fume reaction and the 7-minute reaction. First, look at the circle I designated with an orange arrow in the 1-minute photograph. Notice the conspicuously dark round center, which is the pore orifice, and the contrasting lighter color above and below it. The color contrast is remarkable considering the timer is at 1 minute. This rapid, lighter coloration on the ridge should be attributed to fluid traces from the pore duct reacting to the superglue fumes. Second, let's look at the same pore in the 7 minutes photograph. Notice the dark center still exists, but the ridge above and below it features a significantly contrasting white coloration. In my assessment, this clearly is a single active pore, and it displays an equal amount of fluid on the upper and lower portion of the ridge. Moving away from that pore, the matrix response is gray in color. Note how white the pore site became after 7 minutes and how it was gray after only 1 minute. Let's move to a pore cluster indicated with a red arrow. Notice there appears to be 3 active pores emerging after only 1 minute of fuming. Now let's compare that reaction with the completed process at 7 minutes. The 3 active pores are plainly visible due to the white coloration. However, something else is remarkable in this photograph. Notice that there are 2 pore orifices in the matrix that are gray in color. The orifices in the gray area of the friction ridge are inactive pores. It's my assessment that these pores are visible in the matrix, but since they are inactive, they exist on a ridge structure that appears gray in color. Okay, one more color assessment indicated with a brown arrow. The 1 minute photograph clearly displays the pore's circular diameter. 2 responding pores appear, but the fuming reaction is very weak. Now let's look at the 7 minute photograph. Notice the perfectly formed active pore with upper and lower ridge structure response. Now let's look at the other 2 pores. The only location that displays ridge structure is the area adjacent to the active pore. Significantly, the ridge structure not associated with active pores is barely visible, and the fumes were only able to develop the active pore sites. This leaves only active pores to represent the ridge structure that exists. To summarize, we studied the in situ friction ridge structure and pore response through controlled breathing exercises. In these ground truth inquiries, we were able to watch and record how quickly friction ridge surface can go from a dry to a wet to a dry condition. In this process, the fluids secrete through the pores, and the fluid also returns back under the skin, resulting in the dry, wet, dry surface condition. Our initial superglue inquiry exhibited how rapidly traces from active pores respond to the fumes and how this process can be recognized in a matter of minutes. We later discovered that the matrix did not contain the active pore traces, responded slowly, and from a coloration standpoint, much less dramatically than active pores. In the skin observation, we utilized the LED light reflectance, and in the fuming observation, we relied upon clearly defined coloration response. These observations will prepare us to conduct further superglue inquiries.